G'day and welcome to the world of computers.
From abacuses to iPhones, it's been quite a ride. But have you ever stopped to wonder where these clever contraptions came from? Believe it or not, computers weren't always sleek and shiny gadgets.
Fasten your seatbelts, tech explorers. It's your turn to start or continue your technological journey through life. Grandpop spent his adult life learning about and working on computer systems in the Air Force. He is very excited for you to start your learning journey. There is so much to learn, and the time to start is now. We're about to embark on an exciting journey through the history of computers, delve into their inner workings, and discover why understanding them is like having a superpower in today's world.
The way back before computers existed, like way before. Okay, so before we had computers with screens and keyboards, people still needed to crunch numbers, right? Imagine trying to add up all the sheep in a paddock without a calculator. That's where some clever clogs way back in the day came up with some pretty nifty inventions. One of the earliest was the abacus. Picture a wooden frame with beads sliding on wires. Sounds simple? Well, it was a total game changer. People could add, subtract, even multiply and divide, all with these little beads. Talk about brain power. Along the way, one brilliant invention was the slide rule. Grandpop still has one. Yes, he is that old. The slide rule was invented in the 1620s by William Oughtred, an Anglican minister and mathematician. Oughtred's invention involved placing two Gunter scales side by side and sliding them to perform calculations. He also invented a round one. The slide rule was the primary calculating tool until the late 1980s, when electronic calculators and computers became widely available. Its popularity began to decline in the 1960s. Then came along mechanical calculators like the Pascaline and the stepped reckoner. These used gears and cogs instead of beads, kind of like a fancy clock that could do maths. These inventions were a big deal because they took some of the grunt work out of calculations. So, Babbage's analytical engine was a bit ahead of its time. Fast forward to the 1940s and things start to get really interesting. The world was introduced to the first electronic computers, and these bad boys were huge. We're talking room-sized behemoths filled with vacuum tubes, which are like little light bulbs that controlled the flow of electricity. One of these early computers was ENIAC, short for Electronic Numerical Integrator and Computer. It was a monster, weighing over 30 tons and using enough power to light up a small town. But guess what? ENIAC could perform thousands of calculations per second. That was mind-blowingly fast back then. It was used for all sorts of important stuff, like calculating artillery firing tables during World War II, and even predicting weather patterns. The invention of the transistor in the late 1940s was a real turning point. Transistors were much smaller, more efficient, and more reliable than those bulky vacuum tubes.
With transistors shrinking computers down, things were really starting to cook. Then came along the integrated circuit, or microchip, which crammed thousands of transistors onto a tiny piece of silicon. This was like packing an entire orchestra into a matchbox. The microchip revolutionized the world of computers, making them smaller, faster, and more affordable. By the 1970s, companies like IBM and Apple started making computers small enough to fit on your desk. That's right, the personal computer was born. Suddenly, computers weren't just for scientists and big corporations anymore. Alright, so we left off with computers shrinking from room-sized behemoths to desktops you could actually fit in your house. The 1980s saw the rise of personal computers, or PCs, becoming more and more common in homes and schools. Remember those clunky boxes with floppy disks and green screens? Yeah, those were the good old days. But things were changing fast. Companies like Microsoft and Apple were in a race to make computers more user-friendly. Graphical user interfaces, or GUIs, replaced those boring old command lines. And suddenly, using a computer was as easy as clicking a mouse. And then came the internet boom. What started as a way for researchers to share information quickly morphed into a global phenomenon. Email, chat rooms, and websites popped up like wildflowers after a downpour. Remember dial-up internet? The screeching sound of connecting, waiting forever for a web page to load? Ah, memories. The internet changed everything. It connected people from all corners of the globe, revolutionized communication, and opened up a whole new world of information and entertainment. From desktops to laptops, making computers mobile. Now, remember those bulky desktop computers? Well, they were great and all, but what if you wanted to take your work on the road? Enter the laptop. These portable powerhouses packed all the punch of a desktop computer into a slim, sleek design. No longer were you chained to your desk. You could work, play games, or browse the internet from anywhere with a power outlet. Laptops became a symbol of mobility and freedom, allowing people to work remotely, stay connected on the go, and even enjoy a bit of in-flight entertainment. But the miniaturization didn't stop there. Mobile phones, once just for making calls, started to get smarter. Remember the first iPhone? It was like having a mini computer in your pocket. Touchscreens, apps, and mobile internet revolutionized the way we interact with technology. The future is now AI, quantum computing, and beyond. Hold on to your hats, tech explorers, because things are about to get really futuristic. Remember how computers used to be all about crunching numbers? Well, now they're learning to think for themselves. We're talking about artificial intelligence, or AI, the stuff of science fiction. AI is all about teaching computers to learn, solve problems, and even understand human emotions. From self-driving cars to virtual assistants like Siri and Alexa, AI is already changing the world around us. Who knows? Maybe one day you'll have a robot best mate to help you with your homework. And then there's quantum computing, which is like something straight out of Star Trek. These super-powered computers use the principles of quantum mechanics to perform calculations at speeds that would make even the fastest supercomputer look like a snail. Quantum computing has the potential to revolutionize fields like medicine, materials, science, and artificial intelligence. Unveiling the computer's brain. Meet the CPU. All right, tech explorers, we've time-traveled through computer history, but now it's time to get under the hood and see what makes these digital marvels tick. First up, let's meet the brains of the operation, the big cheese, the head honcho itself, the CPU. CPU stands for Central Processing Unit, and it's like the computer's brain. It's a tiny chip that does all the thinking, calculating, and decision-making. Think of it like the conductor of an orchestra, telling all the other parts what to do and when to do it. The CPU is a real workhorse, constantly processing instructions from programs and making sure everything runs smoothly. It's like a super speedy calculator that can handle millions, even billions of operations per second. No wonder it gets a bit warm in there. The heatsink is used to dissipate heat from the CPU, keeping it cool. The GPU, or Graphics Processing Unit, handles rendering images and videos, making it crucial for gaming and graphic design. The fan helps in cooling various components by circulating air inside the computer case. Lastly, the Power Supply Unit, PSU, provides the necessary power to all the components, ensuring they function correctly. Section 2. Data highways and memory lane, the motherboard and RAM. Now, imagine the CPU as a bustling city center. It needs roads and highways to transport data to and from all the other parts of the computer. That's where the motherboard comes in. The motherboard is like the computer's central nervous system. It's a big circuit board that connects everything together. The CPU, RAM, hard drive, and all the other components plug into the motherboard, allowing them to talk to each other and work together as a team. But what about memory? Just like we need to remember things, computers need a place to store information while they're working on it. That's where RAM comes in handy. RAM stands for Random Access Memory, and it's like the computer's short-term memory. Section 3. Storage galore and peripherals, your computer's sidekicks. Now, RAM is great for temporary storage, but what about all those important files, photos, and games? That's where storage devices come in, like the hard drive. Think of the hard drive as the computer's long-term memory. It's like a giant filing cabinet where all your data is stored safely, even when the computer is turned off.
Section 1. The language of computers. It's all just ones and zeros. Now you might be wondering how computers actually understand all these instructions. After all, they don't speak English, French, or even Aussie slang. Computers have their own secret language, and it's called binary code. Now, binary might sound complicated, but it's actually quite simple. Imagine a light switch. It can only be in one of two states, on or off. That's basically what binary is all about, just ones and zeros. In a computer, everything is represented using these ones and zeros. Each one or zero is called a bit, and 8 bits make up a byte.
In the early days of computing, programmers had to write instructions directly in binary code, which was a bit of a headache, to say the least. Imagine trying to write a whole book using only ones and zeros. Thankfully, some clever clogs developed programming languages to make life a bit easier. Programming languages are like translators between humans and computers. They allow us to write instructions in a way that's easier for us to understand, and then they convert those instructions into binary code that computers can execute. One of the earliest programming languages was assembly language, which used short codes called mnemonics to represent machine instructions. It was a step up from binary, but still pretty cryptic. Over time, higher-level programming languages like Fortran, COBOL, and C were developed, making it even easier to write complex programs. Today, there are hundreds of programming languages, each with its own strengths and weaknesses. Some popular ones you might have heard of include Python, Java, JavaScript, and C++. These languages are used to create everything from websites and mobile apps to video games and artificial intelligence. Section 3. Coding Crusaders. Why learning to code is like having a superpower. Now, you might be thinking, why do I need to learn how to code? I'm not planning on becoming a computer scientist. Well, here's the thing. Coding is becoming an increasingly valuable skill in almost every industry. Think about it. Computers are everywhere these days, from the phones in our pockets to the cars we drive. Learning to code is like learning the language of the future. It allows you to communicate with computers, control them, and even create your own digital masterpieces. Coding can open up a world of opportunities, whether you're interested in designing video games, building websites, analyzing data, or even just automating boring tasks. It's a skill that can take you anywhere you want to go. And the best part is, you don't need to be a genius to learn. Section 1. Computers, your ticket to shaping the future. Now, let's talk about why understanding computers is like having a superpower in today's world. Remember how we talked about computers being everywhere? Well, it's no exaggeration. From the moment you wake up to the time you drift off to sleep, chances are you're interacting with some form of computer technology. Your smartphone wakes you up. Your breakfast cereal was probably made in a factory run by computers, and even your school bus might have a computer on board to help it run smoothly. Computers are revolutionizing every field imaginable. In healthcare, they're helping doctors diagnose diseases earlier and develop life-saving treatments. In transportation, self-driving cars are just around the corner, promising to make our roads safer and less congested. And in fields like space exploration, computers are our eyes and ears on distant planets, helping us unravel the mysteries of the universe. Pretty amazing, right? The possibilities are virtually endless. And the best part is, you can be a part of this exciting technological revolution. Section 2. Stay curious, keep learning, and embrace the techie adventure. Knowing how computers work and how to control them through coding is like having a magic wand that can make your ideas come to life. You can create your own games, design websites, analyze data to solve problems, and even build robots that can do your bidding. But it's not just about the technical skills. Understanding computers also helps you develop critical thinking skills, problem-solving abilities, and a thirst for knowledge that will serve you well in any field you choose to pursue. The world is changing faster than ever before, and technology is at the forefront of this change. By embracing technology and learning all you can about computers, you're setting yourself up for a future filled with exciting possibilities. So, stay curious, keep exploring, and never be afraid to ask questions. The world of computers is vast and ever-evolving, and the more you learn, the more you'll realize just how much there is to discover. Who knows what incredible technological marvels you might create or be a part of in the future? The possibilities are as limitless as your imagination.
Section 1. Keep on computing, little legends. Well, tech explorers, we've journeyed from the humble abacus to the mind-blowing world of artificial intelligence. We've dug into the guts of computers, met the CPU, RAM, and all those other brainy bits, and even cracked the code of binary. Remember, computers might seem like magic, but they're just tools, powerful tools that we can use to create, connect, and explore. The world of technology is constantly evolving, and that's what makes it so exciting. The more you learn about computers, the more you realize how much there is to discover. So keep those curious minds buzzing, stay hungry for knowledge, and never be afraid to experiment and explore. Grandpop became interested in technology when he was just a young boy. Back then, electronics mainly worked using vacuum tubes, which took a long time to warm up before they would operate. He didn't see a transistor radio until he was 7 or 8. They were amazing because you could carry a radio with you wherever you went. Now you can carry a whole computer in your pocket. The first desktop computer he saw was when he was about 20. It wasn't powerful like today's computers. It was very slow and had very little memory, but he found it amazing because it was a new invention. Just think how much computers will change during your lifetime. Who knows what amazing things you'll achieve if you get interested in computers and coding now. You will have the power of technology at your fingertips. Keep on computing, little legends, the future is yours to shape. Never stop learning all you can. From your friends Grandpop, Tester and Evaluator at Wise Hooter Learning, no spaces.